An algebraic sentence is a group of mathematical symbols arranged to form an algebraic relationship. The symbol equal functions much like the English verb is. Here are some examples of word sentences and their algebraic translations. Let's go through these. A number is 3. So we could just substitute in, let's use the capital letter N as our number variable. A number is 3. So is our equal sign. You can even just write a double line under your is, so you know where that equal sign goes. And if you look here, anywhere it says a number or an unknown quantity, you could put your variable, and then you could put this, and whatever that number is, and it tells you n equals 3. If we just look at it like this, it becomes that. Over here, the second sentence says 5 more than a number is 9. So let's look at that. Is our equal sign. 5 more. So if you have 5 more, it means you're adding 5, right? So we could put plus 5 here. And then we have a number. We don't know what that number is, so that's our n. And then we have the number 9. So when we put all that together, we could say, we could either say 5 plus n equals 9, or we could say n plus 5 equals 9. Because of the commutative property, it doesn't matter which one of these is first. We know that adding, you can do n plus 5 or 5 plus n, and it's the same thing. Moving on to the third sentence, here's our equal sign is. We have a number 11 here, and twice a number. Twice is a fancy way of saying 2 times. So 2 times some number. And we know when we have a multiplication times a variable that we just write them like they're factors right next to each other. So we would write 2n equals 11. Twice this n, 2 times n. We don't have to write the multiplication symbol when we have a coefficient and a variable. So on the fourth sentence, we find our is, that's our equal sign, and then our equals 14, so we put our 14 here. We have our a number. This is our unknown or our wild card. So we put our capital N for our variable. 1 less, that means we're going to be subtracting 1. 1 less than thrice a number. 1 less than thrice. Thrice is like twice. It's a fancy way to say 3 times. So 3 times n. So 3 times n minus 1. So that's what we would write. 3n minus 1 equals 14. Last sentence, we have 6 times the number. I'm going to just go ahead and put 6n right here. Increased by 5. So it tells me we're adding 5. Is 17. So the number sentence here would just be 6n plus 5 equals 17. So I would look for that is. Find your is and make that your equal sign. Then pick it apart and find, okay, what is the equal to? What is going on here? Is 11. So then you can go ahead and actually put equals 11 and then figure out what goes before. Or you can start at the beginning and work it out piece by piece. But this is what we call an algebraic phrase, and this is what we call an algebraic expression. And an algebraic expression is the numbers and letters that we use to create an algebraic expression or to create an equation based on an algebraic phrase, or put a little bit easier, a word problem. That's what most algebraic phrases are word problems. So an algebraic phrase is just another or a fancy way to say word problem, and an expression or an algebraic expression is just a fancy way of saying a number sentence that has an unknown, that has something we have to figure out in it. Okay, so let's clear the page. Let's do example 90.1. All right, so 90.1 we have the sum of twice a number and 42. So don't let this distract you. When it says the sum of, that just tells you that there's going to be some numbers added together, and it's telling you to get ready because it's going to tell you which ones are being added together. So your key that you're looking for is and. And means it's a conjunction, and means to combine. When we have English class, or when we're studying grammar, we know and is a conjunction. It tells us that things are joined together. We can have a compound subject or a compound predicate or a list of things, and joins those things together. It is the same thing when it comes to word problems. And is used to mean plus. It's combining these things together. So the sum of tells us that there's going to be some things added, and is going to be between the numbers that have to be added. Or it's going to join the list of things that have to be added. So we know that we have, this is our plus sign, and the twice a number, we have that a number thing here, and twice is just the fancy way of saying 2 times. So 2 times a number, so 2n, plus, and it tells us 42. Here's our is, we know is equal, and then it tells us 128. So our equation or expression is 2n plus 42 is equal to 128. Now we can solve for n. So what we're going to do first is we want to get n by itself. That's the whole point, is figuring out what n is. So in order to do that, we've got to get rid of this 42. We've got to take it out of the problem. So we're going to subtract it from both sides. Because it's an equation, to keep the equal statement or the equation true, whatever you do to one side, you have to do to the other side. So subtract 42 from both sides, right? Draw our line. This cancels, so we have 2n left. And this is going to be 6, and this is going to be 8. 2n is equal to 86. Well, we know that 2n is the same as 2 times n, right? So twice this number. So we know that the inverse operation to multiplication is division, so we are going to divide both sides by 2 because we want to get n by itself. 2 over 2 is 1n. We know that 1 is invisible here. 1n is equal to 43. So now we know what that is. Here's the most important thing that you can do whenever you solve an algebraic equation or an algebraic expression. What you want to do is you want to take the number that you solved for and put it back in the original equation. We want to take that original expression, 2n plus 42 equals 128. And what we want to do is we want to take this n, 43, and put it back in here. 2 times 43 plus 42 is equal to 128. 2 times 43 is 86. And now we check that. 86 plus 42. If you pull up your calculator, you can add those together and you will see that 128 is equal to 128. So when you get this by putting this number back in, then you know you did your math correctly. So check your work each time you have a problem like this, because sometimes if we misread this, that'll be why we get this wrong. And so it will force us to go back and look at this and make sure we got it right in the first place. We got the equation right in the first place. It should solve fairly simply. It shouldn't be super complicated at this stage. So go back and check it and make sure you can sub the value of n back into the original equation and get the true equation statement that one side is equal to the other side. So let's do 90.1. Sorry, I said 90.1. I meant 90.2. We'd already done 90.1. So here's our problem, or our word problem. We have 27 less than the product of 3 and a number is 144. What is the number? So we see we have is, that's our equal sign. So equals 144, right? That's where we have this last bit, okay? So 27 less, that means we're going to be subtracting 27 from something. So 27 less than the product. Product means multiplication. So what things are going to be multiplied? Here we have that conjunction again. So it's putting together 3 and a number. So we're, instead of adding, now this is telling us that we're going to multiply, right? So it's going to be 3 times n. That's what we're doing here. 3 times n is the two things that are being multiplied because it says product. So 3 times n, and we're going to take 27 away from that. So our solution or our equation is going to say 3n minus 27 equals, I'm going to move that over, 144. That is our equation. So we're going to solve for that equation. Now we have to get n by itself to find out what n is. So in order to do that, we've got to get rid of this negative 27. So let's add 27 to both sides to keep it equal and to get n by itself. So this cancels. 3n is what remains on this side. We add this together, we get 11, carry the 1, that's going to be 7, so 171. So now we're going to divide both sides by 3 because we know 3 times this number, they're factors. So we need to find out what this number is by doing the inverse operation, which is division. 3 divided by 3 is 1. 1n is going to be equal to 57 because 57 times 3 is 171. Okay. So now we check. So we say 3 times 57 minus 27 is 144. So 171 minus 27, when we put that in the calculator, we find that 171 minus 27 is 144. So that is correct. 144 equals 144. Always check your work and you'll know if you are on the right track. If you can't get this, then redo the problem. All right, let's see if we have another problem, and we do. So when it says what is the number, we can say 57 is the number, right? Because we have that right down there. So let's do 90.3. All right, so 90.3 says 4 more than the product of a number and 33 equals negative 95. So it said equals instead of is, so we already have that. So we know that something is going to equal negative 95, right? Because we got that from this and this. So now let's look at the rest of it. 4 more. 4 more implies that we're going to add 4 at some point. And when we see 4 more than the product of, we know that that's multiplication. The product of what? This and joins those two things that are going to be multiplied against each other together. So we have a number, which is n and 33, right? So these are the two things that are going to be multiplied. So we could say 33 times n plus 4. Let me make that bigger and all together. 33 times n plus 4 is equal to negative 95. And that's our equation. So again, we want to isolate the n and get it by itself. So we're going to subtract 4 from this side. But to keep things equal, we're going to subtract 4 from this side. So this cancels. 33n, I don't know why I keep forgetting to write the first 3, is equal to a negative 99. So when we divide both sides by 33, we find that n is equal to negative 3. So we're going to take this and check our work, and we're going to say 33 times negative 3 plus 4 is equal to negative 95. So negative 33 times negative 3 is a negative 99 plus 4. We know that negative 99 plus 4, when we put it in a calculator, it's going to tell us that's negative 95 is equal to negative 95. So that's correct. So always check your work and make sure you can balance it. And if you can balance it, if both sides are equal to each other, then you know you did your problem correctly. And that's all we have for lesson 90. I will see you in lesson 91.